Okay, so Niels Bohr came up with this electron cloud model, where again the nucleus is the central core of an atom, a lot of empty space. Of course, this diagram doesn't do justice to the proportionality, but a lot of empty space between that nucleus and the first set of electrons. And any electrons that exist for that particular atom, they exist in particular what we call energy levels. And we'll learn more about these energy levels and how many electrons exist in any one particular energy level. There are rules to this, which they had found out, but we're kind of skipping that just for the moment. You may remember from previous, classes in middle school or whatnot, that the first energy level can hold up to 2 electrons. The second energy level can hold up to 8 electrons. The third up to 18, and there's another pattern there. If you don't remember that, that's cool, that's fine, not a big deal. But the point is, certain electrons exist in certain energy levels. So here, for example, I have lithium. Lithium has an atomic number of 3, so there should be a +3, there should be 3 protons here. 3 protons, it's gonna have some neutrons. That's my nucleus, right? Electrons live on the outside. Well, if I have 3 protons, I better have 3 electrons. And those electrons live in specific energy levels. We know, and we'll learn later why, there are 2 electrons in that first energy level, and then that gets full, and then another electron, the last electron, lives in the second energy level. And this is when it's at ground state, meaning there's no excited electrons jumping levels and jumping back down. And the theory is that this outside electron, this one here, is the most important electron because that's the electron that's going to be bumping into all the other atoms, right? If I had, say, another atom of fluorine, and I'm not going to draw all the protons because it would take me a while, but fluorine has 9 protons, and fluorine would have 9 electrons. And so we would have the 2 electrons here, and then 1, 2, 3, 4, 5, 6, 7 electrons on the outside. That would be a total of 9. So, those first 2 electrons in the first energy level, the remaining 7 in the second energy level, totaling 9 electrons for fluorine. Now, the idea is it's these outside electrons which are the most important because they're the electrons that are going to bump into other atoms. So these electrons bump into those electrons, and that's when reactions could happen. Matter of fact, if these were to meet, it'd be a pretty ferocious reaction. And we'll get into reactions, of course, later in the course too. You're going to hear that often. We're going to talk about that later in the course. That's the way chemistry works. We've got to pick a starting point, but typically other things could possibly be going on. So you don't know everything all at once. But eventually, if you stay in chemistry over the year, you get to learn the big picture. Anyway, these outside electrons, well, they have a special name. They're called valence electrons, because those are the electrons that are bumping into other atoms. These inner electrons do not get as involved with chemical reactions. Yes, in some atoms, those inner electrons do get involved, but generally not as involved. They're not as important. And so what we can do is say, all right, well then look, lithium has that one outside electron. That's the most important. Yes, there's 3 total electrons, but lithium's got that one outside electron. Okay? So fluorine, again, has 9 total electrons, but it's those 7 electrons which are the most important. And so what we do is we represent that in an organized fashion where we put the symbol of that electron. And then we take the amount of outside electrons, again, valence electrons, and we represent those valence electrons as little dots. and we put them around the symbol. So here, lithium, with a little dot over it, is telling you, and by the way, this is called a Lewis dot diagram, this is telling you, so lithium has one valence electron. That's what this Lewis dot diagram tells you. And here, I have fluorine, and I'm going to represent fluorine with a Lewis dot diagram, and what we're going to do is, we're going to put a dot here, okay? And pretend around each side of the element symbol there's two spots. One spot, two spots, one spot, two spots, one spot, two spots, one spot. So there's up to 8 spots around an element, if you will, for these dots. And so, and there's an order technically. Technically, you're supposed to fill 1 dot per side. So 1, 2, 3, 4. But we're not done because fluorine has 7 outside electrons. Then we fill the other dot, 5, 6, 7. It looks nice and neat. Now, if there were an 8th dot, it would go here, but fluorine doesn't have an 8th dot, so we're not going to worry about it. So this is the Lewis dot diagram for fluorine, representing 7 outside electrons. The most you're ever going to have for dots, as you can see with the pattern here, is 8. You're never going to have more than 8 valence electrons. If you do a dot diagram and somehow you draw something with more than 8 dots around the element, you did something wrong. So I'm not going to go through all of the rest of the elements, but I do want to show you a pattern that's going on here. If we look at any element from the first column of the periodic table, that means this whole column here. Any element, whether it be lithium or hydrogen or sodium or any other element, so let me go pick sodium. Any element here, because it's in the first column, has only 1 dot. Again, we'll explain why later, but just want to show you right now so it's kicking around in your head. The second column, where we have beryllium, magnesium, and so forth, in the second column, we have 2 dots. We're going to skip all of the middle of the periodic table. We're going to skip that. There's a reason why. If you go to the 13th column, well, we're going to focus just on the 3. Now, so here we have boron and aluminum and a lot of other elements, but we're going to focus just on the 3 of the 13, and we're not going to put 13 dots. And that's what a lot of students want to do. No, we're just going to put 3 dots. And if you go to the 14th column, you will get 4 dots. 1, 2, 3, 4. If you go to the 15th column, you get the pattern now. I'm going to draw it up here. You get 5 dots. 1, 2, 3, 4, 5. That's nitrogen. That's a really weird looking N, but let's try to fix that up. And you go to the 16th column, you got it. You're going to have 6 dots. 1, whoopsie, not the right way. 1, 2, 3, 4, 5, 6. If I go to fluorine, as we discussed, you're going to have 7 dots. 1, 2, 3, 4, 5, 6, 7. And if you go to the 18th column, you're going to have anybody here, except for helium, which we'll talk about later, but we're going to have 8 dots. So I'm going to go to neon, not hydrogen. I'm going to skip that. And we're going to have 8 dots. Okay? Now, I'm going to tell you a little bit more in a moment, but I got to take a little break. So I'll be right back. Okay, so to summarize, if you happen to know the column that an element is in the periodic table, because of the way the periodic table is arranged, and again, we'll go over why and how that happened later. So if you're in the first column of the periodic table, you're going to have 1 valence electron, 1 dot. Any element in the second column is going to have 2 valence electrons, 2 dots. Skip the middle section, very complicated. There's things going on there we're not going to worry about right now. 13th column, Well, we're going to have 3 valence electrons, 3 dots. 14th column, 4 dots. 15th column, 5. 16th, 6. 17th, 7. And 18th is 8, except for hydrogen. Or I'm sorry, not hydrogen, except for helium. I'll deal with that later. So, for example, if I were to ask you about another element, let's look on our periodic table. Let's find the element number 31, Ga. Ga is here, gallium. It's in the 13th column. It's got 3 valence electrons. So again, 1, 2, 3. Some people in some books will say, you know, it's got 1, 2, 3. It's okay. It does have 3 valence electrons. It's got 3 dots. But again, the pattern generally is you fill in 1 dot per side before you start doubling up dots on each side of the element. If I were asked about, say, bromine. Bromine is number 35. So bromine, which is here, well, it's in the 17th column. So that means it's going to have 7 dots. 1, 2, 3, 4, 5, 6, 7. If I were asked about barium, barium's number 56. Barium is all the way down here. Ba. But it doesn't matter, because if it's in the 2nd column, it would only have 2 valence electrons, because it's the 2nd column. So that's the pattern. I hope it makes sense. Again, we skipped a lot of the reasons as to why, but we will get to it as the year progresses. Thanks.